Maybe we should get started.
Sure.
Okay. So, yeah. Hello, everyone. It's nice having you all here. Today, we're gonna walk you through how to use spatial data to create a wildfire risk index, which nowadays, as a consequence of climate change and the continuous increase in temperatures that we're experiencing, is very, very important to aid in minimizing wildfire impact. But well, first, let us introduce ourselves. My name is My name is Lucía. I'm a data scientist here at CARTO, and I've been recently working with our partners from WeatherSource to create this wildfire risk index. And Mark, if you want to introduce yourself, I'll hand it over to you.
Yeah, thanks, Lucía. Yeah, Mark Gibbas, CEO here at WeatherSource. We're delighted to be partnering with CARTO on this project. We were able to bring our weather information into their platform, and Lucía and her team has done some fantastic work developing this wildfire index. So we're excited to show everyone this. Okay. So I'll take it from here for a few slides and then pass it over to Lucía in just a little bit. But just a little bit of background first. Just looking at some statistics to give us some measure of what wildfire activity has been lately. If we look at last year in the state of California alone, just the state of California, there were over 8,000 wildfires that burned. And this consumed about 2.6 million acres of forest land. So, that's just one state, 1 year. And this has a huge impact, of course, on people and insurance and everything else. So just kind of one example of the kind of magnitude of wildfire activity that we're seeing in recent years. Let's go to the next slide. And wildfire risk is just increasing as we have seen over the past 5 years, 10 years. It seems every summer season we see these increasing amounts of wildfire activity, and it's not just a fluke thing. As we listen to the experts, we see that wildfire risk is increasing kind of uniformly in the U.S. West and in other areas around the world as well. So there's various stats that you can look at. 1 in 6 Americans now live in areas with significant wildfire risk. And we have states like California that are, kind of indicating that this is a priority for them to pay attention to because the risk is becoming so extreme. So let's go to the next slide. And, the stakeholders here are kind of across the board, right? So you have people, of course, people and businesses that are affected by wildfires. But also government agencies, they need to be able to plan for wildfires, react to wildfires, manage wildfires. You also have the insurance group that needs to be able to process all of the damage that is occurring by wildfires. You have power and utility interests that have to navigate wildfires. And of course, anything to do with managing land use and everything else too. So you have all of these different bodies that are kind of need to react to wildfires. So that's why it's really important that companies like CARTO and WeatherSource kind of get together to be able to provide more intelligence on wildfire activity and a wildfire index. Let's jump to the next one. And I think we have a poll. So, all right. Question for everyone out there. Are you currently using weather data and/or spatial analysis when analyzing wildfire risk? And we have several choices here. If you could take a few minutes and let us know if you're using any of this information right now, that'd be very helpful for all of us. Give you a few minutes to chime in. Okay, and we have some answers. Oh, looks like we got some pretty good representation. About 20% of you suggesting that you use this information every day. Another 55%, using it occasionally, and only about a third, or 27%, saying that you're not really using this right now. So, as we can see, wildfire information and wildfire indices are very important. Some of you using this almost every day or close to it. So definitely on everyone's mind, the risk of wildfires. Let's jump to the next slide. Okay. I wanted to go over kind of the key ingredients for what it takes to kind of create wildfires. And there's basically 4 components. You need to have the vegetation fuel, trees, shrubs, all of that needs to be present. You need to have fuel for the fire, as they say. You need a persistent pattern of heat and drought. Okay, so what this does is it dries out all of that fuel, all of that vegetation, and kind of gets it ready to be able to burn quickly. Another key ingredient is wind. Just having the persistent heat and drought is definitely an important step in the process. But having some wind that can actually move the flames around and kind of force feed air and oxygen into the flame, that is an important part. And then the final piece is a spark of some kind. This often happens through perhaps trees falling on power lines, such as in this picture here. The wind can contribute to that. So you have trees and other things interfering with the power lines, creating a spark. Also get sparks through activities such as lightning and so on. You put all this together. You have the vegetative fuel. You have the dry conditions. You have the wind. You have the spark. That's really the ingredients for what kicks off a wildfire. And then, after that, once it gets going, it can be very hard to stop. There are measures to do that. Of course, there's firefighters out there, but the other thing that really helps is weather that can, any kind of rain or precipitation that can come in and kind of help get that under control is what's important for stopping that. So that's the ingredients. Let's move to the next slide. As I mentioned, warm conditions, dry conditions are important for this. If you take a look at what's happening with the climate crisis, and I only have several decades up here, according to NOAA, what we see is that the weather patterns have shifted. The occurrences of kind of extreme cold are kind of going away. We do not see a lot of cold record temperatures happening very much anymore. Instead, what we see is kind of a higher frequency of warm records, temperature records that are exceeding what has happened in the past. And this is happening more and more around the planet. So overall, what this chart is showing you is that global warming is manifesting itself in just more heat, more broken temperature records, and so on happening more frequently. So overall, what we can see from this is that the planet is warming. And from a meteorological perspective, what this means that a warming planet means more atmospheric energy. This leads to stronger atmospheric dynamics. This leads to more weather extremes, more drought, also leads to stronger winds. And then the end result of kind of adding all of this up is you have an environment where you're going to have more wildfires. So this is just part of the pattern of what we see as part of global warming and the climate crisis. So it's important that we have, good intelligence on wildfire risk, because it's not just a fluke. It's going to be around for a while, and we're going to need to plan for it. So let's go to the next slide. As I mentioned, we're really happy to partner with CARTO on this. WeatherSource has a wealth of weather information that can be used for this type of analysis. I've listed a number of our products here. on the chart. I won't go through all of them. I think you'll have perhaps you can have a copy of this. You can browse into it later. But if there's anything we can do for any of you in terms of being able to do the analysis, these are some of the products that we have available. And a lot of these can be very useful in understanding wildfire risk or any other type of environmental risk that you might have to deal with. So, and of course, a lot of this is available through CARTO as well. So at this point, I'm going to hand it off to Lucía, and she can take it from here to describe how CARTO created the Wildfire Index.
Thank you very much, Mark. Yeah, so as Mark has just mentioned, having suitable data helps us to understand how, when, and where fires occur. But we need the proper tools to work with it. And here's when CARTO brings it all together, from taking the weather data from weather source and other additional data sets to then visualize the data, enrich the data from using the data from all the different sources and analyze it to finally build the wildfire index. So basically what CARTO does is to bring all the data here to life. And here's how we did the analysis. And what we did was to examine the fires occurring in the state of California, because this is a region that continues to experience longer and longer wildfire seasons as a direct result of climate change. So we thought that selecting this region or this area to perform our analysis will be very, very useful. So one of the main things that we first discovered was that the major causes of wildfires were basically unknown or unidentified, while others have been associated with lightning or several human activities like smoking, playing with fire, campfires, or even vehicle crashes. And we think that all of these insights are very, very useful, and we need to consider those in our analysis in order to define and create our index. What else did we see? We saw that back in 2020, there was, as you can see here, a drastic increase in wildfire activity. And this is a year when the largest fire occurred in California, burning more than 1 million acres. And as you can see from this plot, there is not like a clear pattern that shows how fires occur. So this indicates that it's a complex task when it comes to estimate fire, and this has been studied for so many years. Additionally, we also wanted to visualize especially how these fires occurred. So we designed this map that you can see here, in which each dot corresponds to a specific fire, and its size is proportional to the burned area of each of the fires. And in this map, you can see that we can filter by season and we can filter by year to discover insights about a specific time period that we want to analyze. And again, here we can see the total burned area that is shown on the image, and it is updated every time we filter the data or we zoom in or zoom out. Further insights can be seen from this plot that you see here. That basically represents when fires occurred and how large they were. So the higher we go in the y-axis, we can see that the fires were larger. This is represented in a logarithmic scale. So in reality, these values are much larger than they look here. But the main or the important thing that we can obtain from here is that most of the fires occur during summer and fall seasons. As you can see, each line here corresponds to a specific fire, so that we can see when the fire starts and when the fire ends. And most of the fires appear or occur in these yellowish and red bands that actually corresponds to these summer and fall seasons that I was talking about. So we can see from here that there exists a seasonality pattern in fire presence. So it is very, very important to consider this when creating the index. These are the main data sources that we used to perform the analysis. Of course, we used wildfire data that was provided by a weather source. And we also wanted to include some geographical data to analyze whether some geography-dependent variables would favor fire presence. So for instance, we included the land cover type data that is an open source data set provided by Microsoft that just represents the physical coverage of the Earth's surface, whether it is crops, trees, water, and so on. And we decided to include this type of data because there's a lot of studies that have shown that specific land cover types are more prone to fire than others. So we thought that it would be very interesting to include this type of data in our analysis. Additionally, we also included the Copper Gauger climate classification data, or KG climate data, which is also available open source. And it assigns a different climate group based on seasonal patterns that depend on precipitation and temperature. And also we wanted to see if other features would favor fire presence. For instance, if you remember, I mentioned that one of the reasons why fires occurred was related with vehicle crashes and smoking. So we wanted, for instance, to see if fires occurred close to freeways because of smokers throwing cigarettes to the road, or because of accidents occurring in the roads. And we also wanted to see if, for instance, fires occurred in remote areas where there is almost no population because of, for instance, lightning striking to a tree. So for this purpose, what we did was to use population and elevation variables from the CARTO spatial features dataset that is available in our CARTO data observatory. And we also wanted to compute the kilometers of roads and the distance to the closest road using the roads data provided by Natural Earth, which is also available in our CARTO data observatory. And in these images here, you can see like the different data that we use, especially so that we can better understand how the dynamics of the data look like. Apart from these kind of like static features, we also wanted to incorporate some temporal information in our analysis. As we saw earlier, the seasonality here is very important, so we cannot miss temporal information when creating our index. So for this purpose, we included meteorological data, which also was provided by weather source, and we decided to use SPI and soil moisture data. The SPI is basically a drought index that is measured at different time scales, and the negative the value, the more dry is the area that we are studying. And the soil moisture data just represents the water content of the soil, and it's also measured at different depths below the surface layer of the earth. And of course, the greater this value, the larger the percentage of water that we have. And lastly, we also used median income data from the sociodemographics data set provided by the American Community Survey that is also available in our data observatory. We use this data to discover further insights about how can this index be used for specific use cases that we will see later on. So once we have all the data gathered and kind of like selected, we have to define a proper methodology to finally build on or create our index. So what we did was to follow these 3 steps that you can see on this slide. So what we first did was to cluster the data and divide it into different groups. And then we created a different index for each of these clusters. What we did next was to find those variables that were actually related with burnt areas. So from all this set of variables that I've just previously mentioned, we had to statistically prove that they were actually influencing fire presence so that we could use them to estimate our index. And once we have our variables selected, we just combine them into just a single variable that can then be used or can then be categorized into different risk levels that we assign to have our final index. I'm gonna explain this a little bit more in depth so that we can better understand how this process was completed. So in order to cluster the data, what we did was to use the land cover type data, because as I previously mentioned, different land covers types are more prone to fire ignition than others. So as you can see here, the trees and the shrubs shown a larger percentage of burned area than other land cover types. So we selected those to perform or carry out our analysis. One interesting thing to mention here is that this area that you can see corresponds to the Death Valley, which is actually a desert region. And it was labeled as shrubs in our land cover type data set. But since this desert does not have any vegetation or things like that, it was kind of like biasing our results. So to remove this area, what we did was to use the KG climate classification data set that has a specific label that represents this type of climate regions to remove this section from the data that we were going to use to build the index. So this is like the final region that we used to estimate and create our final index. And as you can see, most of the fires lie within this region. So now that we have our clusters defined, what we did was to find those variables that were actually fire precursors. And depending on the nature of the variables, we perform one method or another. For instance, for those variables that were the geographical ones or the static ones, what we did was to compute the correlation between those variables and the burned area. And as you can see here, we have the different variables: population, elevation, road kilometers, and distance to the closest road. We have represented the correlation of these variables with the burned area, and as you can see, the values are very, very low. So we cannot state that there exists a significant relationship between these. So we had to remove those from our analysis, and we did not use them in order to create our final index. And on the other hand, for the temporal variables, what we did was to perform a causal discovery analysis that is used to statistically estimate causal patterns from time series data, including time lags as well. So basically what we found using this analysis are relationships between time series data. And as you can see here, the arrows are the ones showing the dependencies between variables. And these were the results that we obtained using this analysis. As you can see, we only found relevant links with the burned area using the SPI variables, but we couldn't find any relationships with the soil moisture. So our final index will be based only on this SPI information. So once we have these variables selected, which are indeed the different SPI accumulated variables, we have to define our index. Here, before explaining how the index was finally created, I wanted to mention that we created two different indexes, one which was an annual index and another one which was seasonal. And each of these can be used for specific use cases. For instance, the annual index is constructed to evaluate the risk of ignition during a specific year, so that it can be used to gain like a general picture of fire-prone areas for that specific year and compare it with previous years. And the seasonal index was developed to be more like specific for each of the seasons. So we have a specific index for each season, so that we can compare the risk of fire within different seasons. Or for instance, we can see for different seasons which areas are more prone to ignition than others. So in order to build this index, what we did was to combine these SPI variables into a single one. And we did this by computing a weighted average in which the weights were obtained as the inverse of the inverse of the confidence interval value that we obtained when using the causal discovery analysis. So the wider the confidence intervals, the lower is the importance of these specific variables to the final index. And once we have our weighted SPI index, what we have to do is to split this histogram into different sections using what we did it using a k-means clusterization algorithm. And this way, what we do is to find the cutoff points that separate the values into different risk levels that go from very low to very high. And in practice, in order to define the risk for a specific time period, what we had to do was would be to calculate this weighted SPI index for the forecast data. And then, for instance, if we have a value of 0, we would just have to go to our map here and assign a risk level of medium, as you can see, because it corresponds to what we have in our training data. And we did this independently for each of the different clusters that we had. And for the seasonal index, we repeated the same process, but instead of grouping the data by year and location, we did it by season, year, and location, so that we have a specific index for each of the seasons independently. And here in these maps, what you can see are the results for each of the two indexes that we built. So for instance, here in the annual index, we can see a distribution of the risk levels throughout California. We can filter by risk if we want to focus on a specific risk level for our specific use case. And the seasonal results will be very similar, but we can also filter by a specific season, depending on the season that we want to analyze. And again, we can filter by risk level, depending on the use case that we are working on. And lastly, I also wanted to show you this use case in which we use the Wildfire Risk Index to improve home insurance. And this would be interesting or important because it may be challenging sometimes for insurance companies to design appropriate wildfire coverage policies in areas where the risk is too high or the risk is uncertain and we don't know exactly what's going to happen there. So having a reliable wildfire risk index provides a competitive advantage in assessing wildfire risk because we can define coverage costs, we can better adjust the coverages, we can design specific plans to make sure that the resources and the personnel that we need are available when needed. And therefore, this would be very, very useful and to have for these insurance companies. And also it can be used to design targeted marketing campaigns. I'm gonna show you here a demo in which we are basically seeing the same map that we saw before about the presenting the results for the annual index, but we have included also an additional layer here in black that represents the top 5% of medium income areas in California, which, as you can see, are mainly in San Francisco and Los Angeles. And if we just zoom in a little bit, we can see that, let me just hide this here so that we can better see the risk levels. These areas actually correspond to areas in which the risk is labeled as very high or high. So some of these the demands of these specific customers may certainly be different from those of other customer segments. And including this information to design our marketing campaigns could be very useful and would allow us to improve in our results. And lastly, I also wanted to mention that most of the data that has been used in this project, including weather sources data, is also available in our data observatory, where you can find more than 10,000 data sets from almost 50 different sources. So if you're interested in this, you can contact us and request a demo, and we will be very, very happy to show this to you. And yeah, if you have any questions, you can just drop them in the Q&A box and we will be happy to answer those.
Thanks, Mark. Thanks, Lucia. We do have some questions here. Hi, everyone. I'm Isa with CARTO, and I'll be moderating this Q&A session. So one of the questions here, Lucia, maybe you can take on this one, is if you have considered other ways to define the final index, right, rather than directly compounding the weighted average.
Yeah, actually, apart from computing this weighted average, what we first did was to combine all these SPI variables into a single one by computing a PCA. And in this way, what we did was to select the first PC component as just the main index, but we found more our results were more accurate using this second approach. So we decided to stick to this one. But yeah, and for sure, there are many other options that you can use to combine the different variables and get just one final index using the information that you had available.
Got it. Right. Thank you so much. Mark, this one perhaps you can take on as this weather source related. The question is if weather source is available only in the US or if it's available globally. Yeah,
absolutely globally. So we cover the planet completely. So any location that you need weather information for, we have that. Also temporally as well. So we have, weather information essentially hour by hour from the year 2000 up to current time, and then going into the forecast. So we have, complete spatial coverage globally and temporal coverage as well. So.
Okay, one more question here. Is the workflow available for sharing for one to create the WRI using the data, or is this a service done through CARTO?
This actually, what we did was to perform all of the analysis using Jupyter notebooks. So you cannot directly, we don't have available a direct tool in CARTO so that you can just put your data in and just click and obtain the results. Like you have to go through the analysis, and depending on the data that you had, you may have to adapt the methodology because as you've seen, we've only considered the SPI variables at the end, but depending on the correlations that you found with the variables and the dependencies that you have, you may have to adapt the workflow that we've followed. So we do not have by now just like a specific tool so that you can just click and get the results.
Thank you, Lucia. Another one here. How would you incorporate geographical data in the final index definition step if you would have found any correlations with the burned area?
Yeah. In this case, yeah, we only found temporal correlations, but we couldn't found any static or any correlations with the static variables. But a good way to combine also this information would be, for instance, to imagine that the population would have been related with the burned area. Maybe you could have used the population variables, the population values, sorry, as some weights that you could have multiplied by to the final index in a way to adjust the final index depending on the population values that you had in each of the specific cell points of the grid. So there are definitely many ways to do this, but one option could have been, for instance, yeah, to use these variables as weights to give more or less importance to the actual value that you've got when computing the index. Yeah.
Got it. Thank you so much. One more question here. Summertime has been one of the main factors increasing the risk of wildfire, and we're entering summertime now. How can we use the index to predict and prevent wildfires going forward?
I'll jump in on that one.
Feel free to jump in. Yeah.
Sure. Yeah. I think it's important that we be aware, right? I mean, the analysis that Lucy has done with her team, being able to reveal this information, how the union of the fuel availability, the SPI index, the population, how that all comes together going into the new season, and using that as awareness for whether it be government or insurance or interest or whatever. I think that's important to view, going into the summer season. And that, it's going to be dynamic too, right? Every season's going to be a little bit different. Prior burned areas are going to be less susceptible to reburning, right? Until the foliage growth comes back and that kind of thing. So it's not the kind of thing where you can just have one view of it and then be done. It's going to be a dynamic thing that you have to check up on every season.
Awesome, Mark. I believe that's it for this webinar. Thank you so much.
All right. Thank you.
Thank you so much.